There is a field in Lancaster County, Pennsylvania, that has been farmed continuously since 1762. 260 years of planting, harvesting, and replanting. No year left fallow. No synthetic fertilizer applied. Not in 1950, when the rest of American agriculture converted to chemical inputs. Not in 1970, when the Green Revolution made nitrogen fertilizer the foundation of modern farming. Not last spring. The soil in that field today tests richer in organic matter, more alive with microbial activity, and more productive per acre than the neighboring fields that have been receiving commercial fertilizer applications for 70 years. The family that farms it is Amish. Their name is Stoltzfus. They have been working that same ground for 6 generations. When a Penn State soil scientist named William Albrecht visited Lancaster County in 1947 and tested Amish farmland against conventional farmland side by side, he wrote something in his research notes that his university colleagues found embarrassing. He wrote that the Amish farmer understood soil biology more completely than the agricultural chemistry department he worked in. That report was filed, not published, not taught, and not cited in the extension office materials that went to every American farmer in the following decade. What Albrecht documented, what the Stoltzfus family has practiced for 6 generations, is a single, unified system for building soil that requires no purchased inputs, improves every year it is used, and produces yields that match or exceed chemically fertilized fields without depleting the ground beneath them. This is that system. To understand why this knowledge was buried, you need to understand what replaced it. In 1909, 2 German chemists named Haber and Bosch developed a process for synthesizing ammonia from atmospheric nitrogen and hydrogen gas. The Haber Bosch process made it possible for the first time in history to manufacture nitrogen fertilizer on an industrial scale. For 30 years, the process was used primarily to manufacture explosives. The same nitrogen chemistry that fertilizes crops also makes bombs. During World War II, the factories that had been producing ammonium nitrate for munitions found themselves at the war's end with enormous production capacity and no military demand. The solution was straightforward. Rebrand the product, redirect the factories, and sell the explosives industry's primary output to farmers as fertilizer. The marketing worked beyond any reasonable expectation. Between 1947 and 1970, synthetic nitrogen fertilizer use in American agriculture increased by over 800%. Crop yields rose dramatically in the short term. The chemical companies made fortunes. The U.S. Department of Agriculture extension offices, funded in part by the same chemical companies, promoted synthetic fertilizer as the scientific foundation of modern agriculture. Albrecht's research on Amish soil biology, which showed that living soil managed through biological methods outperformed chemically fertilized soil over time, was inconvenient. It was not suppressed through any dramatic intervention. It was simply not promoted. Extension agents visited farms with bags of nitrogen, phosphorus, and potassium. Nobody visited farms to document what the Amish were doing with their compost piles. By 1960, an entire generation of American farmers had learned that soil was a substrate for applying chemistry, not a living system to be fed. The Amish never accepted that premise, and their soil shows it. What the Stoltzfus family practices, what every traditional Amish farming community in Lancaster County, Holmes County, Ohio, and Elkhart County, Indiana has practiced for generations, is not a collection of tips or techniques. It is a single, integrated system built around one biological principle: Soil is not dirt. Soil is a community of living organisms. Feed the organisms, and the organisms feed the plants. Starve the organisms, and no amount of chemistry applied to the surface will replicate what a living soil provides. The system has 4 components. They are not optional. They work together, or they do not work at all. The first component is the compost. In the autumn of every year, before the ground freezes, Jacob Stoltzfus builds what his grandfather called the winter pile. Not a compost bin, a pile. It is roughly 8 feet wide, 5 feet tall, and as long as the season's material allows. He layers it in a specific sequence that has been refined across generations. Heavy carbon material on the bottom, spoiled hay, straw, corn stalks, then a layer of manure from the horses, cattle, and pigs, then another carbon layer, then a thin dusting of raw soil from the previous year's garden, then another manure layer, then carbon again. The soil dusting is the element most modern composting guides omit entirely, and it is the most important. That thin layer of raw soil inoculates the pile with the specific microbial communities that the farm's land has developed over generations. Not purchased bacterial inoculants from a garden center, not isolated strains developed in a laboratory. The actual living community of organisms that has been evolving in symbiosis with that particular farm's crops, climate, and soil chemistry for 200 years. Every autumn, Jacob is not just building compost. He is propagating the specific microbial culture that makes his soil work. By the following April, that pile has transformed into something that no chemical fertilizer can replicate. Not because it contains more nitrogen, phosphorus, or potassium than a bag of synthetic fertilizer. It may contain less of each in raw concentration, but because it contains the living organisms that process those nutrients into forms plant roots can actually absorb, protect those roots from pathogenic fungi and bacteria, and build the physical structure of the soil that allows water and air to penetrate. Commercial fertilizer delivers chemistry to soil. Amish compost delivers biology to soil. The distinction is the difference between feeding a patient through an IV drip and feeding them a meal they can digest. The second component is the animals. An Amish farm is not a crop farm that also keeps animals. It is an integrated system where the animals are the fertility engine. The horses that work the fields deposit manure on those fields. The cattle in the pasture build soil, organic matter through their grazing patterns and their waste. The pigs root through crop residue and turn it into the soil. The chickens follow behind the cattle, scratching through manure and spreading it while eating the parasites that would otherwise cycle back through the herd. Every animal on the farm performs a specific biological function in the soil fertility cycle, not as a secondary benefit, as a primary purpose. William Albrecht calculated in his 1947 research that a single dairy cow, managed on pasture through rotational grazing, deposits the nitrogen equivalent of approximately 200 pounds of commercial fertilizer per acre per year through her waste alone. That comes at zero cost and with zero petroleum inputs, while the cow simultaneously improves the physical structure of the soil with her hooves and the biological structure with the microbial communities in her digestive waste. The modern industrial farm replaced that cow with a bag of synthetic nitrogen. The transaction made sense in 1950 when oil was cheap and the long-term consequences of depleting soil organic matter were not yet visible. It makes considerably less sense in a world where petroleum prices are volatile Synthetic fertilizer costs have tripled in the past decade, and the soil organic matter of American cropland has declined by an average of 50% since World War II. The Stoltzfus Farm's soil organic matter has increased over that same period. While American commercial farmland has been losing the biological foundation of its productivity, Amish farmland has been building it. The third component is the rotation. No Amish field in Lancaster County grows the same crop in the same place 2 years in a row. The rotation follows a sequence that has been standardized within Amish agricultural tradition for at least a century. Corn, then a small grain such as wheat or oats, then hay for 2 to 3 years, and then back to corn. The hay phase is the key that most modern analysis misses. During the hay years, the field is not resting. It is being rebuilt. Legumes in the hay mix, clover and alfalfa, fix atmospheric nitrogen into the soil at rates of 100 to 200 pounds per acre per year. The deep roots of alfalfa, which can penetrate 15 feet into the subsoil, break up compaction, bring up minerals from depths no plow reaches, and leave behind root channels that improve drainage and aeration for years after the crop is removed. The rotation is not a sequence of crops. It is a sequence of soil building phases, each one preparing the conditions for the next. Industrial agriculture replaced the hay phase with synthetic nitrogen because nitrogen was cheap and hay required animals to eat it. The animals were replaced with machines. The machines do not produce manure. The synthetic nitrogen replaced the manure. The rotation collapsed from a 4-part biological system to a 2-crop chemical dependency. Corn, soybeans, year after year. On soil that grows progressively less capable of supporting either crop without increasing chemical intervention. The fourth component is the timing. This is the component that Eli Yoder, an Amish farmer in Holmes County, Ohio, described to me in terms I have not found in any soil science textbook, but which every soil biologist I have subsequently spoken to confirmed was biologically accurate. He said the soil is alive in the morning and sleeping at night. Work with it in the morning and everything you do lasts. Work against it in the afternoon, and you undo what the morning gave you. What Yoder was describing, without laboratory language, is the diurnal rhythm of soil microbial activity. Soil bacteria and fungi are most metabolically active in the hours after dawn, when soil temperature is rising and moisture from overnight condensation is available. During this window, applying organic material such as compost, manure, or green material turned into the soil encounters the maximum population of active organisms capable of processing it. Amish farmers have traditionally turned compost into fields in the early morning. They have planted in the early morning. They have cultivated in the early morning, when the disruption of microbial networks is most quickly repaired by the active population present. Modern agricultural schedules are driven by equipment availability, labor contracts, and weather forecasts, not by the biological rhythms of the soil being farmed. This is a small thing, but across 200 years of farming, small things compound. In 2002, a team from the Rodale Institute published the results of a 22-year side-by-side trial comparing organic farming methods essentially identical to traditional Amish practice, with conventional chemical farming on adjacent fields. The results took 3 years to publish because peer reviewers kept asking the research team to recheck their data. After 22 years, the organic fields matched conventional field yields for corn and soybeans. Not close. They matched while using 0 synthetic fertilizer, 0 synthetic pesticides, and significantly less fossil fuel energy per acre. The organic fields also showed 30% higher soil organic matter than the conventional fields, significantly higher biological activity, and the finding that generated the most resistance, continued improving yield capacity year over year, while the conventional fields required increasing chemical inputs to maintain the same yield. The organic system was not just matching chemical farming in the short term. It was building productivity that the chemical system was depleting. The Rodale study was published in peer-reviewed literature. It was not incorporated into USDA extension recommendations. It was not taught in agricultural schools. The companies that sell synthetic fertilizer and pesticides fund a significant portion of agricultural research in the United States, and these findings were not ones those companies had any incentive to amplify. The Stoltzfus family did not need the Rodale study. They have been running the same experiment on their Lancaster County Field since 1762. You do not have a farm. You do not have horses or dairy cattle. You cannot implement the full Amish system in a backyard garden. But the biological principle behind the system is scale independent. Feed the organisms in your soil, and the organisms will feed your plants. The mechanism works in a window box the same way it works in a Lancaster County field. Here is the minimum viable version for a home garden. Build a compost pile, not a bin. Bins restrict airflow and slow the biological processes that generate the heat, which drives microbial activity. A freestanding pile layered in the carbon, nitrogen, soil sequence the Stoltzfus family uses develops temperatures of 140 to 160 degrees Fahrenheit at its core, hot enough to kill weed seeds and pathogens, hot enough to accelerate the microbial activity that transforms raw material into finished compost. The critical element most home composters skip: add a thin layer of raw garden soil from your beds every 3 to 4 layers. You are inoculating the pile with the organisms that already know your garden. Add 1 nitrogen-fixing plant to every bed. Clover as a ground cover. Beans planted at the base of heavier feeders like corn or squash. A strip of alfalfa along the edge that you cut back monthly and leave in place as green mulch. You are replacing a portion of the nitrogen the fertilizer bag was providing with nitrogen pulled directly from the air at zero cost by organisms that have been performing this function for 300 million years. Disturb your soil as little as possible. Every time you till deeply, you destroy the fungal networks that took months to build. Use shallow cultivation of the top 2 to 3 inches to incorporate surface material. Never deep plowing that demolishes the biological architecture below. Leave root systems in the ground after harvest. Pull the tops, leave the roots. Those roots decompose into channels that improve drainage and aeration, and their surface area feeds the microbial community through the winter when you are adding nothing to the bed. None of this requires a purchase. None of it requires expertise. It requires a shift in the fundamental model from soil as a substrate to be filled with chemistry to soil as a community of organisms to be fed with biology. That shift is the entire Amish system in one sentence. In 1947, William Albrecht wrote that Amish farmers understood soil biology more completely than his own department. His report was filed, not published. In 2002, the Rodale Institute published 22 years of data showing that biological farming methods match chemical farming yields while building soil productivity instead of depleting it. The study was published. It was not taught. The Stoltzfus family has been running the longest agricultural trial in Lancaster County history. 260 years, the same field, no synthetic inputs, improving soil every decade. Their results are visible to anyone who drives past their farm and looks at the color of their soil compared to their neighbors. Dark, almost black, loose, alive. The neighboring fields, after 70 years of chemical farming, are grayer, more compacted, and require more inputs each season to produce the same yields they generated in 1960. This is not a contest the Amish are winning through luck or faith or some mystical connection to the land. They are winning it through biology, through a system that was operating in Lancaster County before the United States existed, that survived the Green Revolution by simply not participating in it, and that produces better soil every year it runs, while the industrial alternative produces worse soil every year it runs. The knowledge was never hidden in a vault. It was growing in a field in Pennsylvania, visible from the road, for anyone willing to stop and ask why that soil was darker than the one next to it. Now you know why. This spring, before you buy a single bag of fertilizer, do 3 things. Pull a handful of soil from your garden bed. Squeeze it. If it crumbles into distinct particles and has a slightly earthy smell, your soil biology is alive. If it compacts into a hard ball, has no smell, or smells chemical rather than earthy, your soil is closer to a dead substrate than a living system. That is what you are working with. That is what the system addresses. Start a pile, not a bin. Anything carbon, straw, leaves, cardboard, wood chips, alternated with anything nitrogen, kitchen scraps, fresh grass clippings, any manure you can access. Add a shovelful of raw garden soil every few layers. Keep it as large as your space allows. The biology scales with mass. Start a pile. Plant 1 nitrogen fixer this season. White clover between your crop rows. Beans anywhere a heavy feeder was last year. Alfalfa in a strip you can cut for mulch. 1 plant, 1 season. You will see the difference in the bed it borders by autumn. Nitrogen fixer. The Stoltzfus family did not build 260 years of soil overnight. They built it 1 season at a time, with materials that cost nothing, using knowledge that required no chemistry degree. 1 season. You have the same materials. You have the same knowledge now. The soil is waiting. Leave a comment telling me what your soil looks like right now, dark and crumbly or gray and compacted, and tell me your zone. Your answers shape what comes next. Subscribe.